That's good.
So you do what the exponent says. So in this case, it's squaring both of these. So square -3. What do you get? Square 4 over that, right? So square -3/4.
You got to square both.
Square both of them, because what's being squared? Everything in there. Yeah. All right, guys. Everybody. So hopefully these first few weren't that big of a deal. Convert this into an improper fraction. 3 times 7 plus 2. So 23/3.
Yeah.
Cool. And then this guy, the other way around, you actually have to do the division.
18 to 3.
Yeah, 4 goes into 75 18 times
3/4.
with 3 left over. I like it. And how can you check yourself real easy? 4 times 18 is 72, plus 3 is 75. Sweet. Because only going that way is easier. Number 4. I managed to tell some of you guys a cool little trick. A lot of you guys did this, divided by 2, and they got stuck here. Here's a really cool memorization technique. To figure out if something's divisible by 3, you add up all the digits. If that's divisible by 3, the whole thing is. Let me try this out. So obviously 1 plus 2 is 3, and we already knew 12 is divisible by 3. But what's 1 plus 0 plus 5? 6, which is a multiple of 3, so 105 is divisible by 3. You guys semi with me? So for example, 1280, what, Jeff? I don't know, 1. 1 plus 2 is 3, plus 8 is 11, plus 1 is 12. That's divisible by 3 because that adds up to a multiple of 3. I could just look at that and say, oh yeah, actually this one I could, but you guys, that's a cool little trick. And people are not,
If you ain't ready,
people know those tricks less and less. They used to teach us all the time in 3rd grade, 4th grade. Like what's divisible by 9? Anything that the digits add up to be 9. Right? 9 times 5 is what? 45. What's 4 plus 5? 9. 36. 3 plus 6. Right? How many people knew that? It so sucks. It used to be everybody knew this, and now nobody does. Because those fools back there, they only use calculators, which works, and then they screw you over. And then suddenly you get here, and you got a mean teacher that makes you do things.
Your 9 times, you can actually do, I don't know if you guys did this, but you can do it on your hand.
Yeah. Oh, yeah.
That's 3, that's 27, I don't know if you can see that.
Of course, once you get up to like 9 times 111.
You know, we just borrow some fingers.
So 3 goes into 12. Guys, 3 goes into 12 4 times. And 3 into 105.
35.
Yeah, because it goes 3 into 10, and then 5 into 15, 4/35. Now some of you guys might have taken a different route. Some of you guys might have divided by 3 first. It's easier to see 3 goes into this, isn't it? 3 goes into 21, so it definitely goes into 210. But once I get here, it's not so obvious that 3 goes into this, but it does. So you might have to take a couple steps to reduce a fraction. Now this guy, you guys should remember making those prime factor trees. You don't necessarily have to do it that way, but it makes it kind of nice and organized. What goes into 84?
4 times 21.
Good, 4 times 21. And then 4 is 2 times 2. And 21 is 7 times 3. Cool. So that's 84 broken up into all its parts. Okay. Number 10. How do I divide fractions? Multiply by the reciprocal. Cool. So this would be 4/4 times 4/3. Now nobody, I think one person realized this. What is 4 over 4? 1. 1 times 4/3 is 4/3. Now you could get 16 over 12, but of course the 4's cancel because both the top and bottom has a 4. And you can see that right there. So anytime you can reduce a fraction straight up and down or across when you're multiplying, do it. then your answer is going to be already reduced. That's awesome. 12, once you start throwing variables in, everybody thinks it's going to be so much harder. But variables are just numbers I don't know. They have to act exactly like any other number. So the only thing I worry about with fractions when I'm adding is, are the bottoms the same? Yes. And then I put the tops together. In this case, the tops are like terms. So what's 7x plus x? 8x over 9, and you're done. All right, so variables don't automatically make things harder. They make some things harder, but not everything. When it's just basic stuff like adding, subtracting stuff, they don't really make it hard, believe it or not. 14 gets a little freaky. There's nothing but freaking letters in here. But they have to act the same way numbers do. So what definitely just cancels straight up? The z's, the x's. And the way to look at this, there's 3 y's up here, 1 down there. How many cancel?
2. I mean 1. Sorry.
1 cancels.
There's 2 left.
And there's 2 left on the top. Because again, what's really going on here is y over y. Y cubed is y. Y. Is that an old song? I can't keep track of time. So then y squared. Is that cool? That's going to come up here in a minute with some a's a little bit later. This one definitely freaked a lot of people out. But again, I just threw one little variable in there. Don't think that's going to throw everything off. It doesn't. I still need LCD. Don't make this over 15. What is the LCD here? 10. You could make it 20. But the LCD is 10. So then you get 9a over 10 plus 4 over 10. 9a plus 4 is not 13a. Right? They're not like terms. So what never goes away? Everything you've ever learned. So order operations, always there. Like terms, always required. So forth. Right? It doesn't depend on the section you're in. You're learning everything that's true about math all the time. So up here you get 9a plus 4 over 10. Cool. 18. 18 is going to be a little bit like 14. So at least 18 has a few numbers in it, right? So you start attacking the numbers like you normally would. How does 8 and 16 reduce down?
2.
1 and 2. 3 and 6? 1 and 2. The 2's cancel. And now you got a similar situation. You got 1a on the top, 3 on the bottom. How many a's cancel?
1.
How many are left?
2.
Where? On the bottom, because that's where most of them were. So what do you have on the top, though? 1, because everything else reduced down to 1. How do we feel about that? All right, cool. So I'm trying to show you, when we see variables, we automatically think it's going to be crazy, heinous, bad. And it very often isn't. 20 was definitely one of the harder ones. There are 2 different ways to do this. If you're cool with overloading your mixed number and then adjusting at the end, so you could end up with an answer like 12 and 81/40ths, for example. And then you know how to kind of work with that, that's one thing. Or you can always make these into improper fractions and attack them from there. And I think most of us probably did that second way. Bennett.
Can you use the formula that I showed you so I can know if I proved it here wrong or right?
Do it again, sorry?
The formula that I showed you.
Oh, how to do that one? Yeah, I'll do it both ways. All right, I'll do it improper fraction way first. So this will be 24/31/8. This will be 37/5. 11/4. Now I know there's 3 fractions here, but the LCD is not that bad.
I do like this.
40. Yeah, 8, 5 is 40, and 4 goes into 40.
That's right.
Yeah.
Cool. So if I make them all over 40, so what do I multiply him by? 5. 8. 10. So then I get, something or other. Who knows? 155 over 40? and 296. You guys with me?
Yeah, I broke it down to 81/40.
That's good.
Alright. And now you just have to add those big old numbers together and see if it reduces at the end. So you get something. 551?
561.
61.
140.
And did the problem say to leave it in any certain way?
No, it's simple.
The simplest form.
Simplest form, so it only depends on if it's reducible.
Yeah.
It is. Well,
You could write it as a mixed number, but that's not really reducible.
oh, you're right.
So as a mixed number,
14. 140.
So
140.
I did all that.
14 is 1/20.
140. Yeah, so let me show you the other one. I agree with you, but I've noticed over time that a lot of people don't agree with it. So.
I don't understand. I don't understand it.
Yeah, I don't even wanna watch it. I can't.
I didn't pay attention like that.
So guys, the other way to do this is to leave it as mixed numbers. The LCD is still 40, but now this is going to be 3 and 35/40ths, for example. 7 and 16/40ths. 2 30/40ths. So if you're the more comfortable you are with numbers, the less you normally have to do. Right? So the less comfortable you are, the more you have to do it like that. The more comfortable you are, the more you can handle the answer you get here. You get 10, 12, and what? 81/40. Now, if you stop there, that's not good. That's like uber mixed number. This is a mixed number with an improper fraction. That can't be.
So how many 40s do I
So
get?
a nice way to handle this is, how do I make 81/40ths as a mixed number itself?
2,
40 goes into 81
2,
twice, and how many left?
1, 40,
So 12 and 2.
so 14, 1, 4.
Good, the same thing we got over there. Cool. So it all depends on what you feel comfortable doing. Both ways are valid. Nothing wrong with either way. Just don't stop there if you do this way. You got to keep going and adjust it a little bit. Let's see, where did I stop? This guy is really not too evil. When you divide fractions, you multiply by the reciprocal. Let me first kill those negatives. Is that cool? Negatives kill each other. 16/3 times 12/3. And what is 12/3? What is 12 divided by 3? Yeah. So I get 16/3 times 4.
54.
Beautiful. 16 times 4 is 64. Are you guys semi with me here?
Yeah.
From the beginning, we could have seen that this was 1/4. And then when we flip it, it's 4. But at some point, I can reduce that thing. Anytime you can reduce a fraction sitting in a problem, you do it before you keep going. 64/3. Cool. 24 order operations will save your ass. Oh, Bennett.
So you cannot use again to look at that, because I get 21 for number.
No, you can. You can make it a mixed number, is that what you said? You can make it a mixed number if you want to. Yeah, this would be 21 and a third. Yeah. So here, what's order operations say?
Parentheses first.
Parentheses first. And anytime I have a whole number and I'm adding, subtracting a fraction, I want to make the whole number over 1 so it looks more like a fraction. So what's the LCD going to be in there? 6. So multiply by 6. This guy just comes for the ride for a while, that -2/7. He's got to wait. Because multiply comes after parentheses. Inside I get 36/6 minus 1/6.
35.
35/6.
Is that cool? Stop right there for a second. And now I cross cancel. Right? Please get used to doing this. If I multiply, I get some big ugly number I don't really want to work with. But 2 goes into 6. 7 goes into 35. 5. Good. Negative 5/3. Or negative 1 2/3 if you want. Is that all right? What's up? All right, I'll let you think. 26 is the same idea, really.
Like, oh, because it's between parentheses, so you can simplify it?
You have to. What's order operation says, get done first. Anything inside parentheses gets done first.
Yeah, okay.
Cool.
But here is multiplying. Like, you have
If you want to distribute, you could. I wouldn't really want to.
okay.
Yeah.
I understand.
Cool. So let me bring 26 over here, so it's easier to see.
So sorry, teacher.
Yeah.
24, we can say -1 over 1, 3. 1 2 over 3.
Yeah, negative 1 2/3.
Yeah.
Yeah.
We can.
Yep. Here, order operations again. So what do you do first?
This one.
Good. You have to do in here first. What's the LCD going to be in there? Yeah, it's going to be 6. So you get 4 6 plus 5 6 is
4 plus
9 6. Is that good doing okay so far? So order operations tries to make a big ass problem into many small simple problems. So don't even worry about that guy at first. Your whole problem is just this. So that I've got here. What's next? After parentheses comes exponents. So what's negative 3 squared? 9. And what's 4 squared? 16. Good.
So you just multiply.
Good. Yeah. Now I've got division of two fractions, so I multiply by the reciprocal. So 9/16. Now we could have reduced this. One reason I really didn't is because the 9's go away now, right? You guys see that? So you could reduce 9 6. 3 goes into both. But if I just kind of keep it, the 9's go straight out. That's always nice. And what else reduces there? What goes into both of those?
2, 3, 8. We can open the bracket before this way, when the 4 over 1. Minus 3 over 5.
Not sure what you mean.
Before this. Okay? Can do this before this step. Before divide.
Oh, reduce this?
Over. Yeah.
Yeah, you can do that here. Yeah, sure. Yeah. I mean, the more comfortable you are with order operations, the more you can do at once. Yep. All right, so 2 last ones here. 30 and 32. So guys, bear with me. Let me show you why this works. And this is, we did this at the end of class last time. If I had 3x equals 3, what would you do to both sides? Divide. Because that 3 up top tells you to divide. If I had x over 4 equals 3. Multiply. Because that over 4. Is that cool?
Yeah.
And that's simple. Here I've got both things happening at once. So I should be able to take care of both of them at once. So this is multiplying by -3. So I want to divide by Negative 3. And this is dividing by 8. So how do I cancel division by 8? Multiply by 8. So the shortcut on these, when I have a fractional coefficient, let me say that again. When I have a fractional coefficient, that's what that is, right? The number in front of a variable is a coefficient. This is a fractional coefficient. How do I kill it in one step? Multiply by its reciprocal. Because what happens to the 8s?
They cancel.
Cancel. What happens to the 3s and the negatives? Cancel. So I better do the same thing to this side. So I multiply both sides by the reciprocal. So let me do it again. I got negative 3/8 x equals 3/4. So I immediately multiply both sides by negative 8/3. It's a beautiful shortcut. I am multiplying by 8 to kill the division by 8. I am dividing by 3. So I'm just doing it all at the same time. You don't have to, but get used to doing that. It makes it quicker. The 8s go away, the 3s go away, the negatives go away.
Okay.
So on this side I have x equals
3, 5, 3, 4, 1,
negative 2. Right, the 3s go away, 4 goes into negative 8. Negative 2 times, if you want to do it like that. Okay, hopeful. Let's do another one like that before we do 32. Make it a little evil. So what would I do to both sides?
Negative 11 over 4.
Not negative.
Oh,
No.
So multiply by 11/4.
okay.
5 I can put over 1 if you want to make it look more like a fraction. So those go away. I only have x left, which is what the whole purpose is of solving equations. Equals what? 55 over 4. Yeah. So whatever fraction I have sitting in front of my variable, I can kill it in one step by multiplying by its reciprocal. No trouble. So what about 32? That's where things get a little bit uglier. Here's the really beautiful thing about equations. I can multiply both sides of an equation by anything I want to except 0. What would happen if I multiply both sides by 0? I lose all my information, so you can't solve it anymore. So you can't multiply by 0. I can multiply both sides by 28 billion if I wanted to. I don't want to. I want to multiply by a smart number. In this case, I want to multiply by something that will kill all of my fractions. Now, the minute I show this to people, you start killing fractions everywhere. You're like, I don't like any of them. But why am I allowed to multiply by a number out of nowhere here? Because I do it to both sides. So what do you need to make it legal then? 2 sides. So if I don't have an equation, I can't get rid of the fraction. I just don't. Cool. Okay. But here, this is a special case. I have an equation. I can multiply both sides. What is the number? If I multiply by 3, is that enough?
Yeah.
Yeah, it's got to be 12. It's got to be the LCD. Because 12 has everything in it. We do this again. If I multiply by 3, I kill this one fraction. Will I kill him? No. So I got to multiply kind of like both of these. And make sure that it has everybody else in it also. So that's the LCD. LCD is 12. So if you multiply each piece by 12, you can put it over 1 if you want to. What happens? Here, what happens? 3 goes into 12. 4 times 2? 8 plus. 4 goes into 12. 3 times x? 3x. Equals. 12 goes into 12. Kick ass. 5 is left. Plus 2 goes into 12. 6 times x? Now look at that compared to what it was to begin with. that kicks ass. That is easy. So let's see if it is. Yeah, subtract the 3x if you want to keep the x's positive. It's a good idea. So minus 3x, minus 3x. So 8 equals 5. Careful, plus 3x. Then next step, subtract the 5. So I took the x's that way. I want to take the numbers the other way.
3, so 3x.
And then final step is almost always divide. X is 1. Woo. So anytime you have an equation with fractions in it, the first step you can do is multiply by the LCD. That will kill all of your fractions. It's not the only way to solve that equation, but it's one of the nicer ones. I'll tell you what, that's plenty for me. I don't know about you guys. So next time we'll get into decimals. Yeah.